Hey guys, so this video is about trapezoids and kites. So by the end of this video, you're going to be able to use the properties of each to find missing measurements. So our first figure is a trapezoid. Now there's two types of trapezoids, a regular trapezoid and an isosceles trapezoid. So a trapezoid is just a quadrilateral with one set of parallel sides. So that set are the ones on the top and the bottom, or if it's tilted. We call these bases. Okay? So that's a base and that's a base. So these two are both the bases. Okay? Now, an isosceles trapezoid is a trapezoid where the non-parallel sides are congruent. These two sides. So they would be congruent. We call these the non-parallel sides. These we call the legs. Okay, so you'll notice that these two are parallel. These two will come to a point at the end. Now, they each have a specific property. For regular trapezoids, the angles along the non-parallel sides are supplementary. So these are my parallel sides. What that means is this angle and this angle here are going to be add up to 180 degrees. Okay. So the angles along the legs. So if this is 30, this has to be 150. But it doesn't say anything about these sides for a regular trapezoid. So I could have 160 here, and this could be 20, depending on what the angle measures are. For regular trapezoid, as long as these along the legs add up to 180, that is the only property for trapezoids. For isosceles trapezoids, where we have these two sides congruent, that means that the angles along the parallel sides, or the base angles, are congruent. So if this is 30 and this is 150, that would mean this is 30 and this is 150. So that's the difference between a trapezoid and an isosceles trapezoid. Here's some practice problems. So QR and PS, they are the bases. Okay? PQ and RS are along the sides. Those are my legs. Now, trapezoids also have diagonals. So QS and PR, those are my diagonals. Okay? Now, angle Q and angle S are here. Now, they're not along the base. They're opposite angles. And S and P are along that parallel side. So that is a base angle. So the other thing about this is that we need to know that a trapezoid is never a parallelogram, that the bases of trapezoids are always parallel, that the base angles of an isosceles triangle are always congruent, and the legs of trapezoids are sometimes congruent only with their isosceles trapezoids. So the practice problems with this are just dealing with the angle measures. So the first thing you have to recognize is that there's two tick marks. That means this is an isosceles trapezoid. So if A is 53, B has to be 53. So to find D and C, I would do 180 minus 53, and I would get a grand total of 127. So that's what D and C are. Now for 11, I don't see those tick marks. So I know that A is 91. So that means to get D, I would do 180 minus that 91. That's 89 degrees. For C, I would use the 132. And I would do 180 minus 132, grand total of 48 degrees. Here. And then 12, again, it doesn't matter how many tick marks it has, just matters that it has tick marks. So this is an isosceles trapezoid. So if A is 108, B is 108, And I know that A and D have to add up to 180. So that those two angles have to be 72 and 72. So those are the only properties for trapezoids that we need to figure out. Now, we can complete the rest of these for practice. For a kite, which is a different type of quadrilateral, it says that it's a quadrilateral with two sets of consecutive sides that are congruent. That means that the top two are congruent and the bottom two are congruent, but they're not congruent to each other. And there's no parallel lines anywhere. So that is a key feature of a kite. Now there are three properties for kites. Okay, number one, these diagonals, they're perpendicular, which means they intersect at 90 degrees. That makes all of these triangles in here right triangles. So you have to recognize that too. Also, the diagonal between the non-congruent sides is bisected. Not these two, okay, because this is a congruent side, these are congruent sides. It's the side one that connects the two non-congruent sides. So this, if this is 5, the other side is 5. Okay? So that is key to that too, is that that diagonal is bisected. The other thing doesn't deal with the diagonals, it deals with the angles that are formed by the non-congruent sides. This angle and this angle. What that means is if this is 100, this is 100 also. So you can jump back and forth. Let's do some practice on this. So number 1, in this case number 16, we have to find the lengths of the sides. So this is using this property of the diagonals being congruent. What you have to recognize is that this is a 90-degree angle in here. So that means that this cuts it into 4 right triangles. And I'm looking for that length, and I'm looking for this length. So I have to draw this right triangle separately. Now you might remember, right triangles have that thing called the Pythagorean theorem, or a squared plus b squared equals c squared. So in this case, we would set it up as 2 squared plus 4 squared equals x squared, because x is the hypotenuse. So we do 4 plus 16, we would get 20, and then we would square root the 20 in our calculator, and we would get approximately 4.5. We would repeat the process to find y, only now we have a right triangle that says 2 and 6 and y. So now we're going to do 2 squared plus 6 squared equals y squared, or 4 plus 36 y ends up being the square root of 40, which is about 6.3. So if this is 6.3 and this is 4.5, the bottom here has to be 4.5 and this has to be 6.3. Because these are my congruent sides, these are my congruent sides. So I can finish off like that. For these bottom ones, now I'm dealing with the angle, so I don't need Pythagorean theorem. So the first thing I need to recognize is that I can jump from E to I, because that's the angle that's formed by the non-congruent sides. So if E is 124, I has to be 124. The big question is, what's K? I'm going to just mark that as X. Well, you have to recognize this is a 4-sided figure. So I know all of these angles are going to add up to be 360 degrees, because every 4-sided figure adds up to 360 degrees. So what I'm going to do is I'm going to do 124 plus 124 plus 32. I'm going to get a grand total of 280 degrees. So now I'm going to say, okay, this all has to add up to 360 degrees. So I'm going to do 360 minus that 280. I'm going to get 80 degrees. And that is what K is. I can repeat the process here. Again, this is 118. I to E. And then I would do 118 plus 118 plus 74. And I should get 310. After I get 310, I'm going to do 360 minus that 310. I get a grand total of 50 here. So that's how I find my angles and my sides. So again, whenever I'm looking for the sides, I have to recognize these right triangles in here, 5 and 8 for this triangle, and 6 and 5 for this right triangle, for X and Y. X and Y. And I would do the Pythagorean theorem to solve this. 14 is a little bit more of a challenge problem because now I know the two between the congruent sides, but now I'm looking for A and H. Well, I know A and H both have to be the same. So if I call them X, both of them are X. So I can set up actually an equation that says 2x plus 27 plus 74 equals my 360 degrees. Because I know all four of these added up are going to equal 360. So my 2x plus 101 is going to equal 360. I then would subtract 101, which is those two angles added up. I'll get 259. I would then divide by 2, and I would get each one of these angles is going to end up being 124.5 degrees. So that's how you do the rest of these. So you can complete the rest of these for practice problems, and then come in with questions at the end.